Hello everyone and welcome to C and C++ tutorials for robotics and control engineering. In this C programming tutorial, we explain the basics of memory allocation and the function malloc. Malloc function is used to allocate or to reserve the memory at the runtime. The reserved memory is on the free store, which is also known as heap. The malloc function is defined in the standard header file stdlib.h. This is how the prototype looks and the declaration. Malloc function takes only a single input argument. This argument is the total number of bytes of storage to allocate. For example, to store an integer on my computer, we need 4 bytes. Malloc function returns a void pointer. Consequently, this void pointer is either automatically or manually typecasted to the correct data type we plan to use. Here's the minimal code example that explains how to use the malloc function. First, we will explain this example and then we will compile this example. The purpose of this example is to teach you how to properly reserve the memory by using the malloc function and how to free the memory once the code completes. First of all, we need to include the necessary header files. We include stdio.h and we include the stdlib.h library. Then, at the top of our main function, we use the malloc function to reserve the memory space for storing a single integer. Let's analyze this statement. Over here, we see that the input parameter of the malloc function is the value that's returned by the size of operator. The size of operator returns the number of bytes necessary to store a certain data type. In our case, the data type is integer, and consequently, size of integer will return 4. This means that we need 4 bytes to store a single integer. The number 4 is passed as the input parameter of the malloc function, and consequently, the malloc function will reserve 4 bytes on the free store. And the malloc function will return a pointer to the beginning of the reserved memory space. The pointer is of the type void pointer. And consequently, over here, we cast this pointer to be of the type integer pointer. And finally, the memory address returned by the malloc function is stored in our pointer p. If for some reason the malloc function is not able to reserve the memory, for example, this can be the case if the memory is completely full and we cannot reserve the memory, then the malloc function will return a null pointer. To summarize, if we are not able to allocate the memory, then p is going to be a null pointer. That's why over here we check the value of p. If p is not a null pointer, then we execute this piece of code. Otherwise, if p is a null pointer, there is no reason for doing anything since we were not able to reserve the memory. Then over here we say that the address that p points to should store the integer 100. And over here we print store the value, and we also print the address that's stored in the pointer p. That is, we print the address that's being reserved by malloc, or the beginning address of the memory space that's being reserved by malloc. After this code is completed, we need to delete or to free the memory space. For that purpose, we simply type free p, and after that, we assign p to be a null pointer and we return 0. Simple as that. Next, let us briefly summarize everything we explained so far. This is the main statement. Size of operator returns the size of int data type in bytes. In my case, it is 4 bytes. Then malloc reserves 4 bytes and returns a pointer to the beginning of the reserved memory. Over here, we perform explicit typecast to int pointer. However, this might not be necessary, and often by reading someone else's code, you will see that this person simply doesn't type this. However, you should know that a conversion is being performed since the malloc returns a void pointer, and this pointer is stored in our pointer p. Graphically, p will now point to the beginning of the memory space reserved by malloc. And over here you can see 4 blocks. Every block is a single byte, and these 4 blocks will be used to store our integer. And this is also very important. If there is no memory, a null pointer will be returned. That is, p will become null, and over here you can use the simple if statement to check if p is a null or not. Here, we need to free memory after completing the code. Otherwise, we will create a memory leak. So always keep in mind that whenever you use malloc, make sure that you manually free the memory. Okay, let's start with implementation. As you can see over here, I'm using Visual Studio Code. However, you can use any other C or C++ editor. So let's click on File, New File, and I will call the file as example1.c. And I will create a file, and let's start with coding. First of all, we need to include the standard C library, stdlib.h. Then we need to include the second library. The name of this library is stdlib.h. The second library is used for using the function malloc. Then let's define our int main function, and let's return 0. Over here, let's reserve a memory space for storing a single integer. To do that, we need to type int star p, that is, we need to declare a pointer of the type integer, and then we need to type this int star over here, that is, we need to perform the typecast, then we call malloc, and we pass the return value of size of integer. As mentioned previously, size of integer will return 4. That is, we need 4 bytes in order to store integers. Malloc will return the memory address at the beginning of the reserved memory space, and this memory address will be stored in p. Then we need to double check that we were able to reserve the memory. We simply check if p is not a null pointer. If that's the case, that is, if we have a non-zero memory address stored in p, we can continue. Over here, we type this. This statement will store 100 in the memory address that p points to. And let's print the value. We can say the value stored in the memory address that p points to is, then we use this indicator for integers, and we simply dereference p, and that's it. This statement will simply print 100. Then let's, for double checking our code, print the actual memory address that's stored in p. To do that, we need to type this. The address stored in p is, and over here to print the address we need to use this indicator. And over here I'm going to use a new line, and a good idea would be to use a new line also over here. That is, we need to have new line here and new line here. And don't forget here to write this. You need to actually type this such that you can properly print the memory address. And that's it. After this, we are going to simply free the memory that's being reserved by malloc by simply calling free with the input parameter p. Then we are going to set p to null, and we are going to return 0. And that's it. Although we don't need to return 0 since we already have 0, so let's save this code. And finally, let's compile and execute this code. I will click here and I will run the file. This will automatically compile everything and run. And let's analyze the output. We can see that the value stored in the memory address that p points to is 100, and that's precisely this integer. And we also were able to retrieve the memory address that's actually stored to p. That is, this memory address is the beginning of the memory storage that's used to store our integer. And here is our second example. This example will explain and will teach you how to reserve memory for arrays by using malloc. Again, we need to include stdio.h, stdlib.h, and here's our int main function. The principle is very similar. First of all, I'm going to declare over here a variable that will store the number of bytes necessary to store integers, and I'm going to assign the value to this variable to be the output of size of integer. This statement will return 4, and the value of 4 will be stored in size int. Then over here I define the capacity of my array. It's going to be 6. Consequently, I will create an array of 6 integers. And over here, I'm reserving the memory space for these 6 integers. That is the memory space for my array. So what's happening over here? The input parameter of malloc is 6 multiplying 4. That is, it's equal to 24. Consequently, malloc will reserve 24 bytes in our memory space, and malloc will return the pointer to the beginning of this memory space. And this pointer will be stored in our pointer p. Then over here, we simply assign the values. We say p of 0 is 1, p of 1 is 2, p of 2 is minus 1, etc. That is, over here we fill in the array, and notice a beautiful thing about the C programming language is that we can actually use pointers as arrays. And once we do that, that is after we fill in our array, then we simply print the values stored in our array. After that, we free the memory space, and over here by calling free, we are not only going to free the particular pointer, no, we are going to free the complete memory space. That is, we are going to free 4 multiplying 6. We are going to clear or free all 24 bytes. And after that, we assign p is equal to null, and we return 0. Simple as that. Okay, let's implement and compile this code. So let's click on File, New File, and I will call the file example2.c. And I will save it in the folder. And to expedite our example, that is to speed up everything, we are going to include the same header files, and here's our main functions. First of all, let's type this, size underscore t. Size t is actually a data type that's very similar to unsigned integers. However, it's not exactly the unsigned integer. It's used to define the capacity of arrays, and it's used to define the counter for iterating through arrays. The advantage of using size t over unsigned integer is, first of all, that size t can take a very large value. And secondly, there might be some issues if you're using assigned integers and the code might not be completely portable. Okay, so let's type size t, size integer, and over here I will type size of int. This will return the size in bytes necessary to store a single integer. After that, I will type this size underscore t, capacity, and over here I will specify the capacity to be 6. That is, I want to store 6 integers. Over here, let's type integer pointer p is equal to, let's do this cast over here, and then let's type malloc, and simply we will pass size t multiplying the capacity. That is, we will pass to malloc the number of bytes that we want to reserve. And malloc will reserve the desired memory space, and it will return a pointer or the address of the beginning of this memory space. Then, if we were able to successfully reserve the memory, let's assign the values. P0 is, for example, -1, P of 1 is 2, P of 2 is -3, P of 4, P of 3, actually we are not missing things here. P of 3 is, for example, 10, P of 4 is -15, and P of 5 is 17. And that's it. And now let's print the stored values. For that purpose, I'm going to use the for loop with the size t counter. So I will define declare my I to be of the type size t, then I will initialize it with 0, then I will type this, I smaller than capacity, and over here I will increment my I. That's it. Inside of this for loop, we will simply type this, print f, and over here let's use %d since we are printing integers, and over here let's specify the entry we want to print. After we do that, let's free the reserved memory space. This command, or basically this statement, will reserve all, or actually will free all of our 24 bytes. And then let's assign p to be null. And over here, let's return 0. That's it. Let's make sure there are no problems. And let's click here and let's compile and run this code, and let's see the output. Here it is. Let's make sure that everything is correct. 1, 1, 2, 2, -3, -3, 10, 10, -15, -15, 17, 17, and that's it. Simple as that. But before we conclude this video tutorial, let's change this. Let's see what happens if you're not explicitly converting void pointer to the integer pointer. Will we be able to compile the code? Let's see. And voila, we are able to compile the code. And consequently, you don't need to even specify explicitly the type of the pointer that you need for conversion. Okay, that's all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons, and see you in the next video tutorial.